Hello, tool design students. This is Mr. M here to talk about jig design, chapter 5. Like I mentioned in the startup video, you really should have your learning objectives for chapter 5 in front of you while you're listening to this. That being said, our first objective is recall the definition of a jig. Now, a jig is a work holding device. It's designed to hold, locate, and to support a workpiece while guiding the cutting tool throughout its cutting cycle. So guiding the cutting tool is important to a jig. We talked about work holders before. We talked about how to locate and support a workpiece, but jigs have the function of guiding the cutting tool as well. So a jig can either be a drill jig or a boring jig. A boring jig typically incorporates a support for the tool. Now, as useful as jigs are, they can be expensive. So we want to make sure that you're going to have benefits. So the next objective is recognize the 4 methods incorporated into a jig and the 5 advantages of those methods. You can find this in slide 5 and 6. The 4 methods are to correctly locate the workpiece with respect to the tool, to securely clamp, to guide the tool, and to position or fasten the jig on a machine. So those are the 4 methods that must be incorporated into a drill jig. And then the 5 advantages for the 4 methods, you'll find those on slide 6. And it's to minimize tool breakage, minimize the possibility of human error, and permit the use of less skilled labor, and reduce the manufacturing cycle time, and finally eliminate the retooling. So that was objective number 2. Objective number 3 talks about what is the difference between an open and a closed jig. And you'll find those on slides 7 and 8. An open jig is used when machining on a single part surface, where a closed jig is used when you can machine holes on multiple part surfaces. Theoretically, you could flip the jig over like they're shown here. You see the drill bushings here that guide the tool on this side, and you see the drill bushings here that guide the tool on the other side. So that was your 3rd objective. 4th objective talks about to recall the 6 degrees of freedom of a part and the corresponding 12 directional movements. Now that's actually a review for something that we talked about in chapter 4 when we talked about location of parts. Number 5, recall the definition of a template jig and recognizing the disadvantages of their use. Okay, you'll find this on slide 9 and actually through 12 for the disadvantages. A template drill jig. This type of drill jig does not incorporate a clamping device. The jig is just placed directly on the part to permit the drilling of the holes in the proper location. Now the next slide shows an example of one, in which case what we're doing is we got a part here. You see the part, and you put the template drill jig over it, and then you drill the hole. In this case, we have a bushing here to drill this hole to guide the tool. So that's a flat plate template drill jig. Here's some other template drill jigs. This one here has some locating pins. You place it over the top of a big part, and then you have this 3 bushings for performing some operations, just like we're showing here. That's a template drill jig. These are the disadvantages. They're not as foolproof as most other types. And the orientation of the hole pattern to the workpiece datums may not be as accurate as other jigs. However, the accuracy of the hole pattern within the template jig itself is comparable to that of a conventional jig. And they are not practical when locating datums are dimension regardless of feature size. Just really not practical for that. I'm going to end this movie right here and start a second one. So please review the second movie as well. Thank you.